Hi, I'm Yakov, and this is the Swift Bird. I'm continuing my Swift and iOS Basics series, while at the same time working on a couple other projects. This time, I invite you to explore a topic which may seem very trivial at first, but that's only until you research it in detail. Data types in Swift, more specifically the two major groups of them, value and reference types. How they're similar, where they differ, how you choose one, and why you even need the two in the first place. Subscribe to the Swift Bird if you haven't done so, and give a reference to your colleagues. And if this video looks valuable to you, hit that like button. Making these videos takes a lot of work, but seeing those numbers grow really motivates me. Now, let's start with a high-level overview. In the simplest terms, any computer program consists of two parts: the instructions and the data. In other words, your program has something to do, and it also has something to do it on, or with. These two parts are not separate from each other. Quite the opposite. They interact and sometimes merge into a single entity, to the point where an object which stores some data can also perform operations on the same data. These are basically the key features of object-oriented programming. But for now, let's focus on the data part alone. And as I'm trying to keep these videos accessible to the broadest audience, I'll start with a simplified illustration. Imagine you're working on a text document, and from time to time you need someone else to make edits to it. Conceptually, you have two ways of doing so. You can send that person the document itself, or you can give them a link to Google Docs. Neither of these ways is more superior. Each has its own advantages and drawbacks. For example, the first approach may seem cumbersome in terms of keeping track of the changes and integrating them back into the original. You've probably seen some memes about my document, draft, copy, 3, new version, 4, final, 2. Oh my. But at the same time, it gives you full control over the changes. You don't risk having the unwanted parts edited. The second approach doesn't give you that kind of safety, because anyone working on the document can edit any part at any time. That's not even to mention it doesn't work at all if Google Docs itself becomes unavailable. But on the other hand, you don't have to move every single change back to your master copy. When we are talking about the data in our program, we are basically choosing between the same two approaches. For example, when we need to pass an object as a function parameter, we can preserve the original data and pass around its independent copies. This is known as passing by value, and it mostly occurs with instances of value types. We say such objects have the value semantics. Alternatively, we can share the single object by creating multiple pointers to the same place in memory. This is called passing by reference, which, you guessed it, employs the reference semantics, and it is mainly relevant for instances of reference types. Traditionally, programming languages default to manipulating references. Most often, the pass-by-value approach is available as well, but it is reserved for primitive data types, such as numbers and booleans. And even in that case, the languages often provide wrappers which enable the reference semantics when you need it. For example, in Objective-C, you can use the primitive int type directly. This type is native to the C language and provides no extra features. You can also use the NSInteger type. It's still primitive, but on different platforms it resolves to different underlying types. And finally, you can use the NSNumber class, which wraps primitive values, enables the reference semantics, and supports subclassing. Other languages may even provide one-to-one wrappers, where for each primitive type you get its own reference type wrapper. An example is JavaScript. The idea is primitive types always remain very basic and literal. They have no behind-the-scenes tricks and no attached behavior. And whenever you need to do some action, like transform a string to uppercase, you use the reference type wrappers. But Swift is not like those languages. I wouldn't say Swift pushes you to always use value types, but it certainly makes them a more viable option for your typical tasks. That's because value types in Swift are much more powerful. They're not limited to storing primitive chunks of data. Value types in Swift can be complex objects that store data, implement behavior, and can fulfill protocol requirements. Let's meet the types themselves. Unlike many languages, Swift makes both value and reference types quite comparable in terms of their functionality. However, that doesn't mean you can use them interchangeably in every situation. There are cases where value types turn out to be more efficient. But reference types remain an important part of the language, and in most cases you won't be able to make do with value types alone. especially if you work with frameworks written in Objective-C, UIKit for example. First of all, let's make sure we're on the same page when it comes to the terms. In Swift, when we say reference types, we primarily think of classes, but they're not the only example. Actors, introduced a couple years ago for easier and safer concurrency, are also reference types. Another one, less obvious member of this group is closures. When you save or pass a chunk of code, keep in mind it will be using the reference semantics. Value types also come in more than one shape. While you normally think of structs when it comes to value types, tuples and enumerations are another examples of pass-by-value objects. Actually, enums deserve their own video. That's because in Swift they're much more powerful than in most other languages. And yes, there are scenarios where enums exhibit some reference semantics. You can Google indirect enums if you're interested. But for the sake of simplicity, today I'm only talking about the regular enums. Subscribe to the Swift Burst so you don't miss the in-depth video on enumerations. So, you've got classes, actors, and closures for reference types. And for value types, you've got structures and enumerations. We're not very interested in enums and closures, because they fulfill quite specific use cases. They're kinda unique, because you can't easily swap them for something else. Also, because the difference between classes and actors lies in the aspects we're not considering today, let's leave actors alone as well. So that brings us to the choice that's become classic in Swift. Structures versus classes. They're directly comparable in terms of capabilities, and oftentimes you have a real choice, without a single correct answer. But choosing the type in your specific situation isn't always easy, and understanding the similarities and differences definitely helps. Let's start with the common traits of value and reference types. More specifically, structures and classes, because we agreed to leave everything else aside. So, structures and classes have a lot in common. Judge for yourself. Both allow you to store data and run some procedures. Instances of both can be passed around, used as function parameters, and so on. Both can conform to protocols and fulfill some requirements. And the object which uses them wouldn't even know if you passed a value or reference object. All it sees is the existential type. But that is just scratching the surface. While structures and classes may look very similar from your perspective, behind the scenes they are radically different. First of all, value types store their data directly, because they're just values, in the same way primitives are in other languages. When you assign a value type object to a variable, it stores the actual data, with nothing in between. In contrast, a variable with a reference type object stores a pointer or reference to someplace in memory. I've covered references in the episodes on memory management. If you need a refresher, I'll leave a link in the description. Technically, you can take a variable that stores some number, which is a value type, and make Swift treat it as a memory address. Effectively, you'll be converting a value into a reference, but I don't recommend doing so anywhere outside the playground. Swift won't make it easy for you, and any mistake will probably crash your app. The difference in how data is stored directly affects the behavior you get. With value types, each object is separate and independent, even from its own clones. You can make a copy of your variable, and this copy will be completely isolated from the first one. You can change it any way you want, while the first object will be left intact. Copying reference type objects works quite differently. Instead of getting a separate object, you get a separate reference to the same object. In this illustration, you copy the number which stands for the memory address, but the actual data in memory doesn't get duplicated. Basically, creating another reference will only affect the object's reference count. Oh, and by the way, automatic reference counting only deals with reference types. It doesn't care about value types whatsoever. You can reassign the second variable with a different object of the same type, and just as well, nothing will happen with the first object. You can even reassign the variable with an object of a different type, and again, the original object will stay intact. All of that is possible because the variable is nothing more than a memory pointer. But let's go back to one object referenced by two variables. At this point, you can access the object from multiple places, and if you make a change using one of the references, the other will reflect the same change. This concept of shared state comes handy quite often, but it also introduces the risk of unintended changes, because you don't always control each reference. It's as if you enabled anyone with the link to edit your Google Doc, and one of the editors accidentally posted it on Twitter. So, what do you do when you want an independent copy of your reference type object? Well, that's not an easy task, and it gets ugly very quickly. You need to create a copy from scratch, reassigning each property one by one. And if some of the properties point to other reference type objects, you have to do the same thing recursively. The result is called a deep copy, and it is the only way to guarantee complete independence. Some objects offer a copy method, but it basically does everything I just described, only behind the scenes. However, first you need to read the docs and make sure the method creates a deep copy, not a shallow copy. Another difference between value and reference types is how you modify objects. When you want to change some property in a value type object, you need to make sure both the property and the object itself are declared as variables. That's because when you declare an object as a constant, you effectively freeze it, so even if some of its properties are variables, you still can change them. And the object's methods, which change its own data, must be explicitly marked as mutating. With reference types, you need to check only one place, the property declaration inside the object. When it's a variable, then you can change it, even if the object itself is declared as a constant. Because, once again, this constant is only a pointer to a memory address. Let's take a step back to copying. Assume you duplicated a reference type object by calling its copy method. The question is, are these two objects the same? And the answer is, it depends. What? Don't look at me. I warned you this topic is not a trivial thing. In Swift, the same can mean two things: equal or identical. Here you see that every property looks the same, and if you run checks like this, they all will show that the data is the same. But does it make the objects identical? No, it does not. These objects may be equal, but they're not identical. The notion of identity only works with reference types. When two objects are identical, in reality there's no two objects, there's just one, only it has multiple references pointing to it. But when it comes to equality, you can set the rules yourself. All you need to do is conform your object to the equatable protocol. In its method, you can check the object's properties or just return a static value. So in this case, it all comes down to how you define equality. As you can see, the difference in behavior between value and reference types is quite significant. But the difference in implementation is even greater. Having each value object isolated even from its own clones makes it possible to store objects directly on the stack. Working with the stack is usually faster, because it basically comes down to moving the stack pointer back and forth. Reference type objects reside on the heap, and manipulating the heap is a slower and more complicated process. For example, creating a new object would require the system to find a free block of memory, allocate it, and do a few more things I described in a previous video on memory management. And then there's automatic reference counting, which also adds some overhead. You shouldn't worry too much though. The difference in performance exists, but it is negligible in most cases. And in return, you're getting that shared state behavior we discussed earlier. That difference in storage adds one more distinction to the mix. The program's stack is fast and efficient, but at a cost. Namely, each object stored on the stack must have a fixed size, and the size must be known beforehand. That is the reason why you can't have recursion inside value types. So declaring a struct like this wouldn't work, and neither would declaring an enum like that, unless you use the indirect enum trick I mentioned earlier. So you should keep this limitation in mind. Wow, that's been a lot. But enough with theory. Let's move on to how you actually choose a type. After having learned all of this, you may be asking, how the hell am I supposed to make a choice? And why do we even need two categories of objects in the first place? The first question has a surprisingly simple answer, so I'll get back to it in a moment. Let's start with what's the reason behind all this. Well, as the developers of Swift put it, the language is designed to be fast, modern, and safe. Value types definitely check the boxes for fast and safe, without bringing much extra fluff. And reference types provide greater flexibility just when you need it. Like, I've been using Swift as my primary language for over 6 years, and nevertheless, classes still confuse me sometimes. Because inheritance and dynamic dispatch, some of the properties unique to classes, well, they're complicated things. By the way, I'll do a video on method dispatch in a while, so subscribe to the Swiftbird. Now, let's go back to the first question, how you decide which data type to use. I'll focus on the practical considerations. Value and reference types are pretty similar, but they're not truly interchangeable. Importantly, switching from a structure to a class is way easier than going the other way around. All that leads us to a simple rule of thumb. Just always start with a structure. In most cases, throwing value types at your problem is a safe bet. And as your code evolves, if you realize structures don't suffice anymore, you can replace them with classes as needed. From my experience guiding newcomers, this is something many people get intuitively, and most of them don't have any issues when they follow this path. There's a few edge cases where you need classes right from the start, but you'll probably know about it even before you write any code. For example, when you need to conform your object to a protocol that has the AnyObject constraint, or when a protocol requires your object to be a subclass of any subject, or when you need to make your object subclassable. So once again, starting with value types is a safe strategy in most cases. Basically, that's all I have for today. But before I go, there's one more thing I want to highlight. A big part of today's video was about the difference between value and reference types. And you might get an impression that choosing a type always involves some compromise. For example, value types let you have independent copies of your object, but reference types avoid excessive copying by pointing to the same instance of data in memory. But it doesn't have to be like that. While it's true that the data types differ significantly behind the scenes, you can have the best of both worlds. There's a number of techniques which bridge the gap between value and reference types. One of these techniques is called copy on write, and it allows you to duplicate value objects as much as you want. The copies will point to the same data in memory, but that is only until you change one of the instances. As soon as you do, but not before that, a totally separate copy will be created. In result, you truly have the best of both worlds: efficient memory usage and protected state. Consider this a teaser for a future episode, where I'll be going through all the details of copy on write, including how you can implement it for your own data types. So that is value and reference types in Swift. Lots to learn, but easy to use. I've included both the theory and practical points, so this video can be helpful in your real work, not just job interviews. As always, you are very welcome to leave your additions and questions in the comments. That's it for today's SwiftBird video. If you found it helpful, smash that like button and don't forget to subscribe. You will also find a few links in the description, including how you can support my future episodes. I'll see you later with more tech stuff. Until then, make your references valuable.